Okay, so just really quickly, I decided to combine parts 1 and 2 just because they are both related to the same function. So I was like, why not? Might as well just save some time and space. So I put them all together. We're going to start with part 1 still, though. So for part 1, I'm supposed to show you the graph of a logarithmic function, y equals log base b to the x, and I got to choose the b value, so I went with 4. So our equation is y equals log base 4 of x. First of all, before I graph this, I'm supposed to make a table. So this is the table that I came up with. The reason that we pick the y values and then find the x values is because it's harder to plug, and I don't even know if you technically can, but it's harder to plug an x value into this than it is to just switch it around to this formula and plug a y value into it. So that was really confusing, but basically we're switching this formula to this formula, x equals b to the y power. So the y is still our y value. Our b is 4, and just really quick, I feel like I need to say this. If it doesn't say that there's a base, then the b value or the base is automatically just 10. And then our x is our x value. So it's x equals b to the y, which if we plug in the 4 here, it's x equals 4 to the y power. And then we get to pick the y values. The y values that we've been picking throughout my homework and stuff have been all these -2, -1, 0, 1, and 2. And I honestly don't know why. I don't know if you have to do that, but I figured I would just do that since that's what I've been doing and it's what I know how to do. So then we take these and plug them into this formula. So just really quickly, for example, x equals 4, and then we plug in -2, so it would be x equals 4 to the -2 power, and I had to do this all on my calculator because I'm not really that smart. And so this is our first coordinate, our second coordinate, third, fourth, and fifth. So we got 5 coordinates out of this table. Here is the graph. It's really small, but I will go to the next page and show a better picture of it. So here's the graph like zoomed in. Here are all the points. Number 2 just means like part 2. That doesn't really mean anything. So -0.0625, -2. That's about right here because this is 1, first of all, right here. This line is 1, 2, 3, 4. That always confuses me, so I thought I'd say that. So this is our first point. I color coordinated them too. Pun intended, so that's kind of cute. Here's pink. This is the pink coordinate. Blue right there. Don't know what color this is right there. And hot pink is way up here. So I also need to show you the x-intercept, the vertical asymptote in its domain and range for this whole graph. So how do I do this? Oh yeah. Let's go with purple. So for x-intercept, that is where the line on the graph crosses over our x-axis. So if this is our x-axis, oops, oh no. Hello? Oh no. Okay, so there we go, I'm stupid. If this is our x-axis, then the line crosses over right here at 1. So that means that our x-intercept is going to be, and we're going to write this as a coordinate, which is 1, 0, because it's 0 on the y-axis. Then we'll do our asymptote. Our asymptote is a vertical asymptote, which is our y-axis, which is this. Oh my goodness. Why am I having such a hard time with this right now? Which is the y-coordinate. This is our vertical asymptote, just because the line comes over here. But you'll see in my next one that the vertical asymptote can really be like any line. So it could be 0, 1, 2, 3. It could be any of them realistically. But that would have to be with a different formula, obviously. So our asymptote is this line right here, our y-axis, which is written as x equals 0. I think. I hope so. I never remember. Alright, our domain is the x values that the line on the graph is going to like reach at any point in time. So we can see here that if this is our asymptote, first of all, then it's never going to cross over that, but it's going to get super, super close. So it's never going to go past 0, which means it can never be less than 0. It's always going to be greater than 0, and it's going to keep going up and up and up and up, and it's just going to keep going to infinity and beyond. So it's always going to be greater than or equal to 0, I think. Is it going to be equal to? Yeah, so it's going to be greater than or equal to 0. And because it's our x values, we do x is greater than or equal to. And for our range, it's the same concept, but obviously for our y-axis and our y values. So we can see that our line is gonna keep going down further and further into infinity. It's just gonna keep going. And here it's kind of harder to like see, but it goes outwards more than it goes upwards, if that makes any sense at all. But it's still going up, and it's just gonna keep going up until forever, I guess. I don't know. So because that's gonna technically reach all y values, this is gonna be written as all real numbers.